If so far you've been wondering why we would like to find the dual, by kind of transposing what is related to constraints becomes variable, what are related to variables becomes constraints. Why would we like to do that? Well, this video will answer one of the usage of the duality, in which we may find some economic interpretation of the problem by looking at the dual. So let's start. So to illustrate how we may interpret an LP problem economically using the dual LP, we are going to use Dakota problem and modify the original problem a little bit by deleting this constraint. And then in the next slide, I will pause the video. I will show the Dakota problem so you can read the problem and get the context of this problem. I will return after the pause on the video. So this is the LP formulation for the Dakota problem. We have a maximization case, and these three are the decision variables: number of desks produced, tables, and chairs. We also have three constraints, which correspond to lumber, finishing, and carpentry. Now here's the dual. The dual becomes minimization case, and then whatever that we have as the variables in the original or primal LP problem, in the dual problem, they become the constraint. So we have desk constraint, table constraint, and chair constraint. Whatever that are related to the constraints in the primal problem now becomes a variable in the dual problem. So we have variable for lumber, we have a variable about finishing hour, we have a variable about carpentry hour. So what kind of story does the dual tell? So from the objective function, we can see that we may think of this as if a person wants to purchase all of Dakota's resources. So at this point, you can see that Dakota has 48 board feet of lumber, 20 finishing hours, and 8 carpentry hours. And somebody wants to purchase all the resources that Dakota has. So clearly you can see that the variable y1, y2, and y3 may be defined as the price for each unit of resources. So y1 is the price paid for 1 board feet of lumber, y2 is the price paid for 1 finishing hour, and y3 is the price paid for 1 carpentry hour. So if somebody wants to purchase all of Dakota's resources, the total price that he or she must pay is 48 times y1 plus 20 times y2 plus 8 times y3. Of course, from the point of view of this person, he or she would like to minimize the total price, right? Because that person wants to purchase all of Dakota's resources with as little money as possible. So that's why in the dual problem now the objective becomes minimization, and he or she wants to minimize the total price that he or she needs to pay for purchasing all resources that Dakota has. Now what about the constraints? Well, think about this. If there are no constraints and you only have this objective function, it means that that person who wants to buy all the resources of Dakota may just set the price of y1 equals 0, y2 equals 0, y3 equals 0, right? That will definitely minimize the total price of all resources that he or she wants to buy. But that is not the case here, because Dakota will set the constraints. Dakota say, for example, Dakota will have a chair constraint. The chair constraint means that the combination of 1 unit of lumber plus 1.5 unit of finishing hour and 0.5 carpentry hour, when those resources are multiplied with the price, the total price of this combination must be greater than or equals to 20. Why is this the case? Well, if the price that the person is willing to pay for 1 unit of lumber, 1.5 finishing hour, and zero point 0.5 carpentry hour is less than 20, then Dakota will say, I will not sell these resources to you. I will prefer to use those resources to produce a chair. Dakota can sell the chair with the price of 20. If you are going to pay Dakota less than 20, then Dakota say no. I prefer to use that combination of resources to produce a chair, right? And that is reasonable. So for each of this combination, the price that that person offered to Dakota must exceed the price of desk for this combination, must exceed or at least equal to the price of table for this combination. And overall, the prices that that person offers must satisfy all of these constraints such that Dakota is willing to sell the resources, right? Again, the reasoning is because if the total price of a particular combination is less than what Dakota can get from producing a product, then Dakota will say, I will not sell these resources to you. I would prefer to use these resources to produce desk, to produce table, or to produce chair, right? Because by producing those products, I can sell it with a better price than if I sell it to you when you offer the price of Y1, Y2, and Y3. So that person who wants to buy the resources of Dakota must set the price such that it satisfies all the constraints, while at the same time try to minimize his or her total price, minimize the total price that he or she needs to pay to Dakota. That was about maximization case. Now to illustrate the minimization problem, we are going to look at the diet problem. As before, the next slide will show you the diet problem, so give you the context of this LP formulation. And I will pause the video as well to give you the time to read the problem carefully. So here's the LP formulation for the diet problem. We have 4 decision variables: the number of brownies, scoops of chocolate ice cream, bottles of cola, and pieces of pineapple cheesecake. We have 4 constraints as well: the calorie constraint, chocolate constraint, sugar constraint, and fat constraint. Our dual is a maximization problem. And then because we have 4 decision variables in the primal, we have 4 constraints in the dual. The constraints related to brownie, ice cream, soda, and cheesecake. We have 4 constraints in the primal, so we have 4 variables in the dual related to calorie, chocolate, sugar, and fat. So in this case, what story does the dual tell? Well, we can think about as if a nutrient salesperson wants to sell 500 calories, 6 ounces of chocolates, 10 ounces of sugar, and 8 ounces of fat. So X1 is the price per unit calorie that the salesperson will charge the dieter. X2 is the price per ounce of chocolate that the salesperson will charge. So imagine somebody is selling, hey, I will sell you calorie, I will sell you an ounce of chocolate, I will sell you an ounce of sugar, I will sell you an ounce of fat. And the price of each of those things is X1, X2, X3, and X4. And then of course, as a salesperson, he or she is selling something. So the salesperson obviously would like to maximize his revenue. That's why the dual problem is a maximization problem. Same as before, when we talk about the constraints, imagine if that salesperson has no constraints. It means that the salesperson may just set the prices of X1, X2, X3, X4 as high as possible, right? Because there are no constraints. The salesperson wants to maximize the revenue, then the salesperson just set the price as high as possible. But that is not the case again here, because the dieter, the person who eats or who needs these nutrients, the person may also set the constraints. For example, the person may say that the price of this combination, 500 calories, 4 ounces of sugar, and 5 ounces of fat, the total price of this combination must not exceed 80. Why is this the case? Well, if the price of this combination of this nutrient is exceeding 80, it means that this dieter may just buy a cheesecake, right? A cheesecake only costs the person 80 cents, I think. So if the salesperson sells calorie, sugar, and fat such that the total price of this combination is greater than 80, it means that the person will say, no, I don't want your nutrients. Let me just buy a cheesecake, a piece of cheesecake, and I will obtain the same amount of nutrients, right? Why would I want to buy the nutrients from you when I can buy a cheesecake with a cheaper cost and I get the exact same amount of nutrients, right? So the dieter or the person has the constraint for brownie, ice cream, soda, and cheesecake with the same reasoning. If the total price of the combination that you sell to me is exceeding this one of this food, then I would prefer to just buy the food directly instead of buying the nutrients from you. So the salesperson must satisfy all these constraints while at the same time try to maximize the total revenue that the salespersons obtain from selling all these nutrients that he or she has. Okay, so it becomes interesting, right? Becomes in the original primal problem, the dieter wants to minimize his or her cost in satisfying all the nutrients that he or she needs to consume, while in the dual problem you see that somebody wants to sell these nutrients. Now the person wants to maximize his or her revenue, but then the dieter has the constraint saying that if you sell me the nutrients but they are too expensive, I would rather buy a brownie, I would rather buy an ice cream, and so on. So that's the interpretation of the dual. That's the end of this video, and see you on the next one. Thank you.